So now we're looking at Pythagorean theorem, and we're looking at the converse to the Pythagorean theorem. The first two examples we're going to look at are dealing with finding either the hypotenuse or one of the legs of a right triangle. The first problem, we're looking at finding C, which is the hypotenuse of this right triangle. So we're going to say that 8 squared plus 14 squared is equal to C squared. 8 and 14 act as the legs, C is the hypotenuse, and will remain as C squared. If I square 8, I get 64. If I square 14, I get 196. If I find the sum of those, that will be 260 equals C squared. The final step in most Pythagorean theorem problems is taking the square root of both sides of your equation and finding that the C value here is equal to 16.1. So that's your normal Pythagorean theorem type problem. On the second one, you have a right triangle with sides of 10, b, and 25. So here we're going to be doing the converse to the Pythagorean theorem. The reason we do the converse is because now we have a C value in one of our legs. So we're not going to be able to just find the sum of our legs anymore after we square them. We're going to have to be subtracting. So the converse to the Pythagorean theorem is C squared minus A squared is equal to B squared. So we're going to be dealing with subtraction instead of addition. So if I plug in my values, I'll have 25 squared minus 10 squared is equal to B squared. 25 squared is 625. Minus 100 is B squared. So I will be taking the square root of 525 in order to find my value for B. So this was using the converse to the Pythagorean theorem to find the length of one of the legs of my right triangles. Now the new concept that we learned during Pythagorean theorem was how we can classify a triangle as being acute, obtuse, or right by being given the three side lengths and using the Pythagorean theorem to determine whether they are acute, obtuse, or right. So let's say that we had a triangle that had side lengths of 2, 5, and 6. We'll place these numbers into the Pythagorean theorem with the largest number being my value for C. So I will say that 2 squared is 4, that 5 squared is 25, and that 6 squared is 36. When I find the sum of 4 and 25, that gives me 29. Okay, 29 is less than 36. So my hypotenuse, when squared, is greater than the sum of the legs when they're squared. We talked about this in class, how if you have two different pieces that are creating your hypotenuse. So let's say this pen and this marker were creating my hypotenuse, and the hypotenuse was drawn between these two points. The longer that side gets, the more obtuse that my angle becomes. The shorter that side gets, the more acute it becomes. So if that hypotenuse is longer than the sum of the two sides, we will have an obtuse triangle. Now on your paper, I will be checking this on your notes. Use the numbers 6, 9, and 10 as side lengths and tell me whether they are acute, obtuse, or right. So the side lengths are 6, 9, and 10. The last thing that we're going to do is a problem that you will very likely will see on your test. And it's the same thing that we just did, classifying a triangle as acute, obtuse, or right. But we're going to be using 3 coordinates. We're not going to be graphing these three coordinates. We're going to be using our geometric skills and some algebra to figure out what the side lengths are, and then based on the side lengths, what kind of triangle we have. So we're going to say that side 1 is represented by the distance between -4, 2 and -3, -4. So -4, 2 and -3, -4. Side 2 is going to be represented by the distance between -3, -4 and 0, 4. And then finally side 3 will be represented by 0, 4 all the way to -4, positive 2. So those will be my three different side lengths. Now I have to use the distance formula to actually figure out the lengths of those sides. Remember, the distance formula is a variation of the Pythagorean theorem, except instead of saying A and B, we're going to be saying that the change of y squared plus the change of x squared is equal to my distance squared. My change in y squared is the change between my y values from -4 to 2. That value is 6. The change in my x value is from -3 to -4, which is 1. So that means that 36 plus 1 will give me my distance squared. So I'm looking for the square root of 37. Now I'm going to leave that as a radical because I'll show you in a second why I'm going to do that. We'll do side 2. The change between 4 and -4 for those y's would be 8. From 0 to -3 would be 3. And of course I'm trying to find my distance. So I'm looking for 64 and 9, the sum of those two, which will leave me with the square root of 73. And again, leaving that as a radical, I'll show you why in a second. And the last one, the distance between 2 and 4 is 2. Between -4 and 0 is 4. And we have d squared, 4 plus 16. So the square root of 20 is what will give me that distance. Now, on the problem we did before, where I'm trying to figure out whether they are acute, right, or obtuse, I took the numbers and I put them into the Pythagorean theorem. The highest number ended up being my c value in a squared plus b squared and c squared. I'm going to keep these as radicals because when I square these radicals, the solution will be the number inside of the radical. So I'm going to start by squaring 20 because that's my lowest number. So the square root of 20 squared plus the square root of 37 squared equals the square root of 73 squared. So this side 2 will be representing my hypotenuse, because it's going to have, or my hypotenuse. Not only if it's a right triangle. It's going to be representing the longest side. So when I square these radicals, I end up getting 20 plus 37 equals 73. The sum of 20 and 37 is 57. So that number is less than 73. My longer side is greater than 57, so that means that I would have an obtuse triangle. This is the type of problem that you will see on your test when dealing with acute, obtuse, and right.